In today's video, we'll be looking into the topic of cost efficiency when it comes to hosting on ARM or x86 architectures. We'll analyze the cost efficiency of these architectures across three major cloud providers, Hetzner, AWS, and Azure, to help you make a more informed choice when setting up hosting for your projects. In the rapidly evolving realm of cloud computing, software developers are presented with numerous options when it comes to providers. However, today our focus will be on the ARM architecture as an emerging force in the world of cost-effective cloud solution options. We're going to compare it to the long-established x86 architecture and examine the strengths and benefits of each. While ARM CPUs are more synonymous with mobile devices, in recent years they have become increasingly available on large cloud computing platforms like AWS and Azure, and even more recent cloud competitors like Hetzner. One of ARM's defining features is power efficiency. However, it was commonly lacking in compatibility when compared with x86 for running your favorite open source software or large-scale production workloads. But as these ARM CPUs have become more and more common in more high-powered devices, especially used by developers, the compatibility story has greatly improved over recent years. This means there is an increasing opportunity to save money by migrating some applications from running on the x86 architecture to utilizing the more power-efficient ARM hardware. In this video, we'll be walking through the results of our analysis comparing ARM and x86 architectures running on Hetzner, AWS, and Azure for three different workloads. Our aim is to help you make a more informed decision and raise awareness of the potential cost savings that may arise when considering a switch from your application running x86 to running in an ARM environment. We used three tests to gain the information in our results: a pgbench Postgres benchmark focusing on database performance, a .NET HTTP load test using web services to show web service performance, and a synthetic Geekbench score. Our objective was to offer a comparison of value and capabilities of various instance types across different providers and architectures. By examining these benchmarks, we aim to provide you with a snapshot of the performance characteristics of ARM versus x86 on these different cloud providers. If we look at some results that are isolated to each provider individually, we can see that the most value can be gained by switching from x86 to ARM if your existing workload is already on AWS or Azure. This is especially obvious if you're running your workload on Azure, where a switch to ARM for HTTP workloads could net you a 50 to 60% increase in efficiency and cost reduction. And this trend continued when we switched to looking at our pgbench results for Azure. Here we can see the cost efficiency difference across all our tests, but we're just focusing here on Azure x86 versus Azure ARM, and we can see we have a cost efficiency increase of between 2 and 3 times. And again, we see this for our Geekbench score. Cost efficiency here is how much performance you get for each dollar spent. So for a fixed workload, this means a reduction in costs for the same performance. To put this in more concrete terms, if we go by our numbers from our pgbench scores, if you had a similar workload running on the x86 D4SV3 instances and you switch to ARM running on the D4 PSV5 instances, you would save $132 per month or nearly $1,600 a year. And not only would you save money, you would get a performance boost as well. AWS still has some opportunities as well when converting from x86 to ARM to gain some cost efficiencies and save some money. These cost-saving opportunities are not as clear-cut as they were on Azure, but for large-scale workloads, there's a good chance that Changing your instance type to a Graviton instance could reduce your compute costs. Again, for an example using our PG bench results, if you had a similar workload running on 3 T3X large instances, migrating that to a 3 times T4GX large instances would be a saving of $43 a month or around $500 a year, and with a small performance boost. For those who haven't chosen a cloud provider yet or have some flexibility to move, if you don't need some of the sophisticated managed services that AWS or Azure offer, using an alternate provider like Hetzner will save you way more money than switching architectures. In fact, on Hetzner, the difference between ARM and x86 is quite small until you start scaling those number of cores to above 8 or 16. Another reason for avoiding running your applications on ARM architecture on a provider like Hetzner is that the availability of ARM virtual machines is extremely limited, and at the time of recording was only available in one region, and during our testing we actually had some trouble getting some of the larger instances. This availability doesn't seem to be a problem on Azure or AWS in our testing, as they were regularly available and easily procured just using on-demand or spot instances. So while Hetzner stands out as a provider focusing on great value, AWS and Azure have a multitude of managed services and availability when it comes to alternate hosting options. ARM is really emerging as an attractive, cost-effective option, especially for scalable workloads and web services. And as the compatibility story improves over time, the switch to ARM within one of those larger providers becomes more and more attractive. Switching some of your workloads from x86 to ARM may be straightforward, but as developers, we have to test and make those trade-offs. And the same goes for choosing a provider. Hetzner's focus on value may appeal to those seeking robust performance without complexity, while AWS and Azure may be suitable for those requiring a wide range of managed services. Well, that's it for this video. If you have any suggestions or feedback, let us know in the comments below, or if you've got any experience switching from x86 to ARM, let us know how you went. Alternatively, you could also join us on GitHub discussions or community Discord. ServerStack is free for individuals and open source projects, so anyone is welcome. And as always, thanks for watching.